I didn't really intend to do a Halloween lesson today, but it seemed like a good idea to put a few little reminders up on YouTube for some of the people, both for the people at home, still on remote, as well as the people in class. Okay, so we've been covering ratios, proportions, and unit rates lately. So let's do a quick refresher on a couple things. Ratios are a lot like fractions. You can get a ratio that looks like 2 over 4. You want to reduce it, it's the same as a fraction, and it's 1 over 2. No big deal, okay? So it's just like reducing a fraction. It's exactly like if you were thinking about having, simplest form of fractions or things like that. Okay, I'm a little bit out of practice. I haven't been doing this at-home teaching lessons since I've actually been back in school for a while, which is kind of nice. So let's say you got two ratios and you want to know if they form a proportion, okay? So if they form a proportion, they're going to be equal to each other. So something like this. If you had 2 over 5 and you had 7 over 10, now, if you know fractions, you can pretty much spot in your head when things are going to be equal and when things aren't going to be equal. But, honestly enough, 85% of American students don't like fractions. They prefer decimals. I prefer decimals too. It kind of reminds me of money, makes it easier to work with. But there's a term called cross products. Okay? Cross products means when you multiply in an X formation diagonally. So 2 times 10 gives me 20. 5 times 7 gives me 35. Clearly, that is not equal. And since it's not equal, then guess what? Not a proportion, okay? So clearly they're not equal, they're not a proportion, and that's how you would utilize cross products in order to do something. Now, that's the first kind of part of the review on this. Second part let's go to is going to be having a variable in something, okay? So let's say you were given something like this. N over 2 equals 6 over 8. Okay, and they tell you, hey, solve for what the variable is going to be. So cross product, 8 times n, okay, 2 times 6 equals 12. Divide by 8, divide by 8, and then n equals, 8 goes into 12, once, 8, gives me a 4, gives me a 0, 1.5, okay, 1.5 and you're done. Now, this turns it into a single-step algebraic expression. Okay, so you've got the variable, you've got your ratio, they want to know if it's a proportion, so you use cross product, and then you come through there and you get 1.5. Now some people may choose to reduce one of those ratios to a smaller ratio first, just like reducing simplest form fractions. So divide the top by 2, the bottom by 2, and you end up getting 3 over 4, and then it's 3 over 4 times n over 2, and you're going to come up with the same answer. It's just going to be a little different because you're shortcutting it ahead of time. If you want to take that extra step, you can. If you're comfortable working with sometimes larger numbers, things like that, just go with the cross products. And remember, it always comes to a single step equation, which is then going to be undone by using the inverse operation of multiplication, which would be division. So you divide each side, and then you get your variable isolated for what it is. Okay, those two things are a quick recap about the ratios and proportions we've been working on. Now, mixed into that part of the unit, there's a couple other things too. Now, they said there's 3 ways to write a ratio. So let's say I've got the ratio 1 to 8. Well, I can also write it 1 with the colon to 8, or I can write it 1 to 8. It all means the same thing. It's all 2 numbers being compared through division, but they're presented differently depending on the situation in which it's given. Maybe it's a recipe. Maybe it's a ratio of people in a classroom. Maybe it's a ratio of mixing paint to come up with something you have to do. Like the example I used in class when Bo was talking about painting the Corvette when I was a kid. And you have to put the paint and the hardener and the fix-it and all that stuff together in order to make it work. If you don't, then it runs off the car or it dries in the air and turns all sandy. So there's a very different chemical balance, but that's one application of ratios. Another application of ratios would be pharmaceuticals. You go to the doctor, he prescribes you some medicine. Medicine for somebody who's 160 pounds is going to be a far different ratio than somebody who gets medicine for the same thing who's only 75 pounds, all right? That's, given the wrong medicine, it's either going to have no effect or it's going to have too much of an effect, which could kill you in some cases, especially if we're talking about something like heart medication or blood pressure medication. That could be a problem. So there's practical applications to the ratios, although you might not see them on your everyday life now as you think about it. All right, so let's go one little step farther. This is going to be the last thing I want to run through with you, unit rate. All right, so the example I used in class was unit rate was like, hey, you're going to drive from Sacramento to Las Vegas, and it's going to be about 550 miles, give or take as a crow flies. So let's say you have 550 miles. Okay, that's going to be your distance. Remember this little thing? D over T equals, and sometimes some people call speed, some people call rate. I'm going to go with S and say speed. Kind of depends on different science teachers. I've heard them explain different ways. There's some nuances between the two, but for our purposes right now, just figure that distance is divided by time, and it's going to tell you relatively how fast you're going somewhere. So if it's 550 miles for your distance, and you get there in 5 hours, then you're going to take 550 divided by 5, and that's going to give you 110. Unit rate is going to be 110 miles per hour, okay? Now, does that mean all of a sudden you start going 110 miles an hour from 0 miles per hour? No. It just means that that's the average rate of your travel as you're going from there. We know that when you back out of the driveway, you're backing out at 2-3 miles per hour, then you're going down 15-25 in the residential zones, then you hit in the freeway, you hit 65, and then when you hit that Las Vegas desert, maybe you put the pedal on a little faster and you hit the triple digits somewhere. It's possible. I mean, hey, just watch out. You get to going that fast, you hit a rock and your car can flip right over. So responsibility is the key. But that's a perfect example of unit rate. Now, unit price is calculated the same kind of way, okay? So let's say you're purchasing something and you want to know the per item cost of something. In a class, I used a couple different examples, but let's say you did something like this. Let's say you had 236 chicken wings. Okay, you're going out, you're hitting the Wingstop up, and you love yourself some wings. I love myself some wings, good stuff. So 236 chicken wings. And let's say you and some of your friends are going to be eating them. So let's say there's going to be like 4 of your friends. So 4 people. All right. And you split them all up evenly, and you divide 236 by 4, and you get your answer. Okay. So now let's say it's something a little different. Let's say it's 236 chicken wings. But you're looking for the individual price cost. You bought your 236 chicken wings, and let's say it cost you, I don't know, $129.36. Okay. I'm not going to do the whole problem for you, but I'm going to set it up and kind of show you how to go through it. Why? Because I don't really feel like doing the long division right now, and this gives you the idea behind it. There's some things you should be able and need to work out on your own. Yes, a calculator will do this very quickly. No, I don't have one sitting next to me right now, so I'm not going to do it. And I also don't feel like grinding through the larger problem. Now, if this is dollars, okay, I'm going to take $129.36 and I'm going to divide it by 236. So, boonk, boonk, boonk. And then it's going to give me my individual price. That's going to be like the price per wing. So how many dollars or how many cents it's going to cost per chicken wing based upon what I spent to buy those 236 chicken wings. So this can be utilized in a lot of different ways. You go to the grocery store looking for the better buy. Is the 500 pack of paper the better buy, or is the 180 sheet pack of paper the better buy? Well, it kind of depends. You're breaking it down to the per piece price. Now, the bigger package may be a better deal, but the initial purchase may be more money, so that may not work for you at that point. This all fits in that whole budget thing. Remember, when the bank of mom and dad stops paying off and the gravy train ends, and you can't actually get them to pay for everything, you got to pick up your own bills, and that's called the budget, all right? That's why we did the whole budget thing before. Now, when you're going through these things in your homework, all right, there's some things to keep in mind. There's 3 ways to write a ratio: the colon, the fraction bar, and the word to. Distance over time equals your rate or your speed, okay? So let's just clarify that. This is an equation that you will see in physics, that you will see in science, and it will happen a lot, all right? It becomes extremely useful when you're doing that, particularly in physics. Now, unit rate, it's a very similar setup, okay? You're going to have like your number of items on top and the dollars, you do some division, and you find out what the dollar per price is. Or let's say you have, 10 ounces of perfume and it costs you $29. You do some division, you find the per ounce price. All right, last thing I want to leave you with, though, and this is the most important thing because there's a lacking of common sense in a lot of people in the world today. Oh no, I said that. Shame on me. You get what I say, though. I mean, you understand exactly what I'm talking about. And in math, common sense is really important because, look, in order to check your work, is your answer reasonable? If your initial purchase price for something is $300, and you're trying to figure out, how much 29 items cost each, and your purchase price is $300, and you come up with an answer that is like $500. Clearly, that's not reasonable. You made a mistake. Most common mistake, you reverse the division things, okay? You divided one number by the other number when it should have been the other way around. So look for the reasonableness of your answer. If it's reasonable, then you're probably on the right track, okay? I'm going to leave you guys with that today. That's the end of this lesson. It gives you just a quick checkup and rehash on a couple things we covered this past week in class, okay? Hope you all have a happy Halloween. Take it easy.